Hello, and good afternoon to everybody. Welcome to this session. We'll be talking about AWS Elemental Media Convert. Media Convert was one of the 5 new AWS Elemental services that were announced on Monday. Media Convert is primarily a file-based transcoding service. And my name is Vivek Bhatt. I'm a product manager at AWS Elemental. And I have with me Aaron Sloman, who is the CTO at OwnZones, and we'll be sort of splitting the session between us. So in terms of how we have structured this session, I'll start off by giving some, going into a little bit of detail on what file-based transcoding is, why it's relevant, and what some of the challenges are in delivering video today. And then we'll look at what Media Convert is about. So we'll spend a little bit of time going into the different components, the architecture, some of the key use cases. Hopefully, I'll have some time to pull up the console, do a quick, like a demo job for all of you. And then Aaron's going to come over. He's going to talk about what OwnZones is, what they do. And he'll be spending the bulk of his time talking about Magnolia Pictures workflow that OwnZones built using AWS Elemental Media Convert. And he also has a demo in the OwnZones platform. So what is file-based transcoding? So I'm sure most of you are probably aware of what transcoding is, so I'm not going to spend a whole lot of time on this. But essentially, I just want to draw the distinction between this and live streaming. So file-based transcoding is really, you have source content in the form of files. Now, this content could be shot in a studio environment. It could be shot on a cell phone and everything in between. And you really want to process this content because that's the only way you can sort of get it into different versions that will play back on a range of devices. And as part of this processing, you might want to change the codec, you might want to change resolution, you might want to change the frame rate. And if it's premium content, you might also want to apply encryption, or you might want to apply DRM because you want to sort of control access rights to that piece of content. Unlike live streaming, where you have a real-time constraint, where you need to process video exactly at real time, file-based transcoding can go as fast or as slow as the underlying hardware allows. And you have control over how fast you want it to go by controlling the quality settings, the codec settings, the resolution, and things like that. And historically, a lot of customers have used on-prem solutions. So we'll look at on-prem solutions, what the challenges are with that. We'll look at cloud-based solutions, what the challenges are with that. But the reason why file-based transcoding is important, and the reason why it needs to be a very conscious decision in terms of what solution you pick to do your file-based transcoding, is really driven by these two sort of high-level trends. We're seeing more and more video being produced. So unlike in the past, where a lot of the video that was produced was limited to studios with high budgets, today, anybody and everybody has access to a camera and they're generating video. At the same time, consumer preferences are changing, and there's more and more devices that are being used to view this content. So just, I read somewhere that based on estimates, about 1.6 billion people all over the world have viewed content on a connected device. So that's very, very different from just processing content to deliver to your primary screen, which is the TV over cable or satellite networks. Now there's a lot more happening over the internet. And as content producers and as you're part of like media companies that are delivering content, it's really important to be able to get your content onto all of these different devices that consumers are on. And it's not just converting all of this content into all of the different formats, but it's also being able to sort of have that flexibility and that agility to be able to quickly sort of process this content to take advantage of any new formats, new standards, without having to sort of significantly invest a lot of money into sort of your infrastructure. So let's first look at some of the challenges if you were using on-prem transcoding solutions. So historically, like this has been one of the most popular ways of transcoding content. And this requires that the customer basically buy the software or hardware solutions, and they need to sort of deploy them in their data centers, and they need to sort of manage all of that infrastructure. So that is not just in terms of buying one kind of server from one provider, because there are different vendors who specialize in different capabilities. And as a customer, you had to deal with buying all of the different pieces and then putting them all together, and then sort of managing the scalability of that, because it's fixed boxes, and suddenly if you have a lot of volume coming in, if you have a spike, you don't really have enough capacity to handle that spike. So you were not just sort of, there was no flexibility, and you had to sort of build for your peak. And even at that peak, if for some reason your volume spiked beyond that, you didn't have a way to sort of handle it without sort of going and quickly buying a bunch of hardware, all of which has a lead time. And obviously, it was heavy on CapEx, because you had to sort of make that initial upfront payment. You had to go set up all of these things. You had to interface with multiple vendors. And it was just not efficient from a cost perspective, from a scaling perspective, from an agility perspective, from a flexibility perspective. So then we started to see cloud-based transcoding solutions show up. And some of these solutions basically sort of took a lot of the solutions that were available on-prem, and they moved it to the cloud. Now, while a lot of these have improved the scalability, so you don't have to sort of worry about buying infrastructure and setting it up and all of that, a lot of these solutions basically don't provide the same kind of feature set or capabilities that you would need for a broadcast-grade workflow. And what I mean by broadcast-grade workflow is the support for formats like XTCam, for example, ProRes, or capabilities like HDR, caption support, DRM, for example, and things like that. So there's a lot of providers sort of doing bits and pieces of each, but it's not easy to sort of provide the full range of capabilities that is required for you to process and deliver broadcast-grade content. While they did help with scalability, they're still not completely limitlessly scalable. So what I mean by that is, up to a certain point, as long as you have consistent workloads, things are great, and then you have a certain spike, and then things start to back up. Your turnaround times suddenly start to increase, and you're just not sort of delivering that same high-quality experience to your customer. And a lot of these solutions also suffer from fairly limited support. So in a lot of cases, something goes wrong, you're probably like dealing with a forum, you probably can't get somebody to speak to on the phone. And with video, it's really important that you're able to sort of address some of those issues immediately, because any interruption in your video processing workflow really means lost revenue, essentially. A lot of these solutions also suffer from complicated pricing. So pricing tends to be fairly opaque on a lot of these, and it's really hard to sort of estimate, when you have a given workload that you need to process, what that's going to cost. And without knowing that, it makes it harder for everybody involved, because for you as a customer of this cloud service, you really cannot predict your pricing, which means your customers, you really cannot commit to a particular quote either. And a lot of these cloud services also tend to have manual onboarding. So what I mean by that is they're not self-service, in the sense that to go and use them, you can't just go try out a job and sort of see how it looks and feels. You'll have to get in touch with a salesperson, and there's sort of a fixed ramp-up time, so to speak. And finally, it's not really easy to build end-to-end workflows. Transcoding is just one part of an end-to-end video processing workflow. And while a lot of cloud companies, yes, they do offer transcoding as a service, managing sort of that entire workflow, setting that up, managing conditional states within the workflow, being able to sort of manage error conditions, all of that, it's not really easy to sort of set all of that up in a very flexible manner. So now I want to sort of switch gears and talk about the new service that we just announced. And with AWS Elemental Media Convert, our goal was really to make it super easy to build broadcast-grade workflows in the cloud. And the way we did that was we basically combined the encoding expertise, the video encoding expertise that Elemental had built up over the years with the distributed systems expertise of AWS. And what that really means for customers is that they have access to professional-grade video features and quality. So the same kind of capabilities that Elemental Server has offered over the years within this service. And then it also means that they don't really have to manage any software or hardware infrastructure. So essentially, you're sort of combining sort of the advantages of on-prem solutions as well as cloud, in the sense that you're getting access to a full range of capabilities, and you're getting access to that without having to manage any infrastructure. The service automatically scales in response to variations in your incoming video volume. So as a customer of this service, you don't really need to worry about what happens if I suddenly have a spike, because what that means for you in that case is that you're just scaling up the number of job requests you're making to the service, and Media Convert is responsible for sort of identifying that and then figuring out how it should scale up its fleet and add new instances to the fleet to go and handle that spike in video volume. And then finally, we do realize that customers are the best people to sort of figure out how they want to process their content. So while we have made it easy to sort of build these workflows without having to worry about the infrastructure, we have still retained a fair bit of control for you as the customer to say, these are jobs that are higher priority than another bunch of jobs. And you can sort of decide how you want those jobs to be processed, what the order should be, and stuff like that. So let's look at what the key components are for Media Convert. So the key thing is the primary unit of work is a job. A job is basically made up of an input, one or more inputs really, and then a bunch of settings that define what the outputs that need to be created are. A job can also have metadata. Metadata is basically key value pairs that you define, and those are sort of preserved with the job. So if you want to embed your own sort of intelligence, or if you want to enable some tracking within jobs, you can do that through metadata. Now, all of the settings that define a particular output, so those are things like codec or bitrate and resolution and things like that, all of those, if you're going to be using the same kind of codec and the same kind of settings, you can just save them as a preset. So each preset can basically reference one output. And together, they basically combine an output group. Now, you can imagine that for a given job, you're creating more than one output. Because if you're doing an HLS stack, you're not just doing one video output. You're basically doing like probably 3, 5, 10, or depending on your use case. And those will vary based on resolution, bitrate, and things like that. So you can basically define all of that once and save that as a job template so that you can basically use this template again and again on different inputs. So a job template really sort of saves your input configuration, and then it is a collection of presets or settings, and then any of the metadata and the other job configuration that you want to sort of reuse. So basically, you can create a job from a job template by combining it with one or more inputs. Jobs need to be submitted to queues, and queue is really a logical construct for managing the resources that are available to your account. Now, what I mean by resources is really the number of jobs that you can process in parallel at any given point in time. So every job needs to be submitted to a queue, and by default, every account has access to about 40 job slots that it can use to process jobs in parallel. And jobs, so what that means is if you have just one queue on your account, which every account will have by default, let's say you submit 100 jobs to that queue, 40 of those will start processing immediately. The remaining 60 will wait in the queue, managed by Media Convert, and they'll stay there as long as one of the slots does not open up. So the moment like jobs from that first batch of 40 start to get done, there'll be more jobs that'll be picked off the queue and they'll start getting processed. So with this sort of a setup, you can imagine that if you have a use case where you have higher priority jobs versus lower priority jobs. So for example, let's say that you have this catalog of content that you want to process for a launch that is a month from now. And that has like about 10,000 video assets in it. But at the same time, on an ongoing basis, you're also processing files for which you have SLAs. So you need to turn them around as fast as possible. If you just had one queue, there's a good chance that all of the files in your library that you don't need processed immediately will probably clog up all of your capacity. And you definitely don't want that because you want to ensure that any high priority job that comes in goes to the front of the queue and gets processed. And the way to do that is by creating additional queues on your account. And what that does is it splits the resources available to your account across the queues. So it's essentially like creating reserved lanes within your account, dedicating resources to it. So when you create another queue on the account, each queue can process up to 20 jobs in parallel. And then you can submit your low priority jobs to one queue, so only 20 of them will be processed at a time. And you'll have 20 slots always free for your high priority jobs. So anytime a new job comes in, it'll go straight to the front of the queue and get processed. As outputs are being created, they will be placed into S3. So right now, Media Convert only works with content in S3, both in the input, and you can only generate outputs and place them in S3. And as outputs are being created, they basically go through a different set of states. So when you submit a job, the first thing that happens is there's a bunch of validation steps that we do. And then assuming we can accept that job, it goes into a submitted state. From there, it goes into a processing state, and from there, it can either complete successfully or it'll fail. And at each change in state, Media Convert will publish an event to Amazon CloudWatch. So when you're building your workflows, you don't need to sort of poll for what the status of the job is. You just need to subscribe to the CloudWatch event that's denoting or signifying a particular state change. And then when you sort of subscribe to that event, when the event happens, then you can tie that to another Lambda function, or you can tie that to a step function, and you can sort of drive downstream workflows from it. So yeah, that's essentially what I'm sort of depicting with using the CloudWatch event, and then you can use SMS to send yourself like a message, or SNS for email, and Lambda to run post-processing scripts. For example, that's a pretty common use case that we see. So let's take a quick look at the pricing. I'm not going to put up any numbers here because that's easily accessible by going to the product page. But I want to talk about some key sort of high-level points about our pricing. So there's no minimum fees. So what that means is everything is sort of pay as you go. You're not sort of paying for any monthly subscriptions. There's no upfront payments. So it's entirely based on the number of minutes of output video that you're generating. So let's say that you have an hour-long piece of content and you're generating 5 different outputs from it. You'll be charged for 5 hours of output that is generated. But the per minute rate essentially depends on a bunch of different factors. So it depends on the codec of the output that you've generated. It depends on the frame rate. It depends on quality settings. And by that, I mean whether you use 1 pass or 2 pass. And then it also depends on the resolution. And all of the rates are laid out on the product pricing page. So feel free to go take a look at that. And the last thing is it's pay for what you use. So I just covered that, which is if you're just generating outputs which are 30 frames per second AVC codec SD outputs, that's the cheapest that that has the cheapest rate. Whereas if you're generating like HEVC with 2 pass 4K outputs at 120 FPS, that's going to be significantly more expensive. And these are all basically the rates are based on the outputs that you generate. So each job can have multiple outputs, and each output within that can be will be charged at a different rate depending on what you use. So some of the high-level use cases that Media Convert will be a good fit for. The first one is mezzanine content creation. So as I said, video content comes in a wide variety of flavors these days. On one hand, you have your premium video content that was produced in a studio or that's super high value. And Media Convert can be used to basically create those high-res mezz files that basically can then be sent off to like OTT distributors or whatever so that they can sort of create the ABR stacks for downstream distribution to consumers. So that's the next example, which is Media Convert will be a good fit for any OTT service or a VOD delivery platform that is basically taking these high-res mezz files and then creating the ABR stacks for distribution to OTT devices. And then on the other end of the spectrum and everything in between, you have user-generated content, you have news content, sports content, you have enterprise content, which is anything from training videos to State of the Union type videos. You have social content. And Media Convert can be a good fit for all of those because it has the ability to scale pretty seamlessly, and it's very much a pay-as-you-go. So you can start small if you're one of those customers who's basically more like a startup and you're trying to sort of dip your toes in video. Media Convert would be a good fit for you as well because you don't have to set up this very expensive video infrastructure. You can just say, okay, I'm going to start small. I'm going to pay for what I use. And then if my business grows, if it takes off, then I can sort of grow from there. So in terms of what an end-to-end workflow looks like, this is just a sample workflow. There could be many different variations of it. So as I said, the source must be in S3 for media convert to be used. And one typical way that we've seen sort of customers use media convert is to configure a Lambda function that gets triggered when a new file arrives in an S3 bucket. And that Lambda function is basically assembling a job request for media convert based on the characteristics of the file in S3. And it's assembling the job request, and then it's basically making the job request to media convert. And media convert is then basically processing those files, putting them in S3. And as it's processing the files, it's basically generating the CloudWatch events that you can subscribe to drive downstream workflows. And then once the output is in S3, then you can point a CloudFront distribution to it to then deliver it. You don't have to use CloudFront. You can use any other third-party CDN as well. But we just sort of media convert is only responsible for putting the files into S3. Another key thing that I want to talk about here is another point of integration with CloudWatch. So in addition to the events that sort of signify job state changes, we also publish metrics related to your transcoding jobs to CloudWatch. So those are things like the number of jobs that you submitted, the number that succeeded, the number that failed, how much time did each job spend in the queue, how much time did it spend transcoding. So all of those metrics are available in CloudWatch, and they sort of accumulate over time. So you can go back and look at your historical trends, and you can sort of see where your P90 for your queue time was, where your P99 for your transcoding time was. And because it's all in CloudWatch, you also benefit from the ability to sort of set thresholds on any of these metrics and then alarm on them so that you can take action if a metric sort of gets to a value which is not expected. So a simple use case, especially if you're doing like a serverless sort of a workflow, there is a chance, and we've seen this happen with a number of customers, is there tends to be errors in how they configure this, and they end up using the same S3 bucket for the input and the output, and that results in an infinite loop. And suddenly, before the customer knows it, there's like hundreds of thousands of files that have been transcoded. So an easy way to prevent that is to basically look at the metric, which is number of jobs submitted, and then say if this goes above a certain threshold, which is above your regular usage volume, then just sort of tie that to saying pause the queue on media convert. And that'll basically ensure that you're not processing any more content if you've exceeded the number of jobs that you typically expect within a given time period. So let's look at a few benefits of media convert. So the first one, the thing that we really want to sort of focus on is the broadcast grade workflows in the cloud. And that is really what we're able to sort of provide through the Elemental integration here. And it is the same encoding engine that powers Elemental Server today, that powers media convert. So you have access to the same set of input and output formats. So in terms of codecs, we support HEVC or H.264, AVC or H.264, HEVC or H.265. We support ProRes. We support MPEG-2. And then in terms of audio, we support Dolby Audio, AAC, and stuff like that. And in moving beyond sort of just the video codecs, we have support for HDR. We support static overlays. We support multiple DRM standards. So we support HLS, Fair Play for HLS, AES-128 encryption for HLS, PlayReady and Widevine for Dash, and PlayReady for Smooth. And we've also done a number of integrations with various key server providers. So we've integrated with ByDRM, EasyDRM, Irdeto, Verimetrix, and Conax. And we expect to sort of increase those, the number of integrations over time. And the one other thing is if you're the kind of customer who is delivering premium content and output video quality is really important to you, there's a lot of fine-tuning parameters that you have access to really control the trade-off between the quality of the output to the time it takes for the output to be generated and the size of the output. So unlike some other solutions out there which only give you access to like a few set of parameters that you can control, here, and I'll show you the list of parameters that are there, you really have access to a wide range. We really want to help you focus your attention on your business and not have to worry about the underlying infrastructure. So one of the key benefits is helping you guys be more agile and have the ability to iterate faster and be able to respond to changes or new formats that come out and be able to sort of quickly support some of those things to ensure that you're providing for the highest quality viewing experience for your audience, essentially. So in terms of some of the features that help you sort of do this is it's a completely serverless sort of a model. And then I talked about the integration with CloudWatch already. And then we'll also, over time, we'll be adding Lambda blueprints. We'll be adding reference architecture. And these will sort of showcase end-to-end workflows that combine not just AWS services, but also some solutions that our partners provide. So like we'll have like a QC tool integration reference architecture, for example. So if that's of importance to you, you can sort of see how to build something that sort of incorporates that. Or one of the things that we're doing that we'll publish shortly is conditional transcoding. So what that means is for every piece of asset that you want to transcode, you might want to sort of dynamically set up the parameters for that based on the characteristics of the file itself. And the way we'll do that is through the Lambda again. The Lambda is going to get triggered when that file is going to come to the S3 bucket. Then it's going to basically examine the output characteristics, the input characteristics, and then it's going to assemble the job request appropriately. Media convert really reduces the financial risk for you because, and I already talked about this, it's completely pay as you go, no commitments whatsoever up front, and you're just paying based on the volume of video that you're pushing through media convert. And it's really scalable and super high performance. So you can process multiple jobs in parallel. So I talked about the limit of the default limit of 40 jobs in parallel. That's a soft limit. So if you have a use case that you need more jobs to be processed in parallel for, then that's absolutely doable through the standard service limit increase process on AWS. And then, yeah, so you still have that control over the number of queues that you create. You can control your priority. You can separate out processing between your production jobs, and if you just want to run some, just some testing jobs and things like that, and you don't want that to take up your entire capacity, you have the control to do that. And then finally, we've built a number of mechanisms to ensure that you are building workflows that are robust and resilient. So the first thing is the extensive validation of the settings. So there's just a number of settings when you set up a job. And a lot of times, the combination of settings could be such that the job that is, it might not produce valid outputs. So we have, when you submit a job, the first thing that we do is we validate the settings on the job, and only if the settings are good to produce valid outputs, only then do we accept the job. And then once that happens, we have a number of mechanisms to ensure seamless failover in the event that the particular EC2 instance that is processing that job, let's say it fails or something happens to it, we don't throw an error. We try to basically retry that on another EC2 instance, and then that'll be completely seamless to you, and the job will sort of process and complete. And obviously, it's a multi-zone availability architecture, so you're sort of protected from more widespread outages as well. So before I jump to the thing, I think I might take a few minutes just to do a quick demo, and then I'll hand it over to Aaron. Okay. So this is the AWS console today, and we have a new category of services. These are basically the ones that we announced on Monday. So we have Media Convert, Media Live, Package Store, and Tailor. I'm going to click on Media Convert, and I'm going to go and click on Get Started. And this basically is the screen to create a job. I'm going to set up a fairly simple job. It's going to be a short job because I don't really have a lot of time, but you'll get a sense for what some of the capabilities are. So the first thing is it's integrated with S3. So this is basically, these are all my S3 buckets, and I can pick a file. And then it's a pretty simple file that I've picked as an input, but if it had multiple video streams, program streams, you can select which one you want to use to transcode. And similarly, if it had multiple audio tracks, then you can choose which particular audio track you want to have pass through to the output. We support audio channel remixing as well. And then same with captions. You can choose particular caption tracks. You can add external caption tracks and things like that. And then you can choose to clip your video as well. So what that does is basically you need to specify a start time code and an end time code, and Media Convert will only transcode that piece of the video, and you'll only be charged for that clip. So now I'm going to go ahead and add my output groups. I'm going to create a simple job, so I'm going to choose a file group. So you can also see that we support HLS ABR, the HLS ABR standard, the Dash standard, and Microsoft Smooth Streaming as well. So once I do this, the first thing I need to do is pick a destination for the output. So I'm going to say destination video, and I'm going to say reinvent demo. And then for my first output, I'm going to call it output 1. I'm going to make an MP4 out of it. And this is where you get to see like the complete set of settings that you can control. So to start with, you can, if you want to run a quick job, you can use one of our system presets. So these are a collection of recommended settings across various codecs. But for this one, I think I'll just go through creating a simple MP4. So I have an MP4 container here. So you can see that we support Flash, MPEG-2, transport streams, QuickTime, and MXF. I leave the video codec as H.264, but you can see, as I said, H.265, MPEG-2. We do thumbnail generation as well, called frame capture and ProRes. I'm going to do a 1920 by 1080 job. I'm going to leave all of the other settings as the default settings, but you can go and control, you can play around with these and see what they do. I'm going to leave the bitrate at 5 Mbps. And then we have a number of preprocessors on here, which you can turn on as well. You can turn on the deinterlacer, noise reducer, you can burn in a time code. So you can sort of see the breadth and the depth of settings that we offer in this service. Before I submit this job, now this is a super simple job because I'm just doing one MP4 output. So I have to choose the queue that I want to submit this to. I'm just going to say default queue because I haven't created another queue on this account. The next thing I need to do is to choose an IAM role. And this is important because this is what gives MediaConvert the permission to go access the files in your S3 bucket and to produce the outputs in your S3 bucket. So I've created this role outside of this demo, and I'm just going to use it. We have instructions on how to create this role in our documentation. And then, as I said, you can attach metadata pairs, key value pairs. And then you can also do add avail blanking and timed metadata insertion. So I'm going to go ahead and say create. So you see here at this point, it basically the status is changed to submitted. If there were any errors on the job, it would have just not gone to this page. It would have thrown an error. And I'm going to go ahead and refresh this page. And now the status has changed to progressing. So it means that it's basically, the queue was pretty empty for me because I only submitted one job. So you can see that the duration in the queue is literally 1 second. This is just rounded up. But if you have more jobs already running, then you might see that queue time go up a little bit. It's already complete. It took about 26 seconds. It was a fairly short video because I had to choose a pretty short video for the demo. And the outputs are basically in my S3 bucket here. I just created one output, and there it is, output 1, Big Bug Bunny output 1. And you can see the details of the job that you submitted, so all of the settings. And if you're using the console to basically configure your settings, you can basically say view JSON, and this is going to give you the complete set of output settings in JSON format. So you can just copy this and use this in your code to set up more of an automated workflow. So yeah, that's pretty much it. I just wanted to give you guys a sense of what this looks and feels like. Feel free to go and try this on your own. It's available to anybody and everybody at this point. And now I want to invite Aaron so that we can hear about OwnZones.
Thank you, everybody. And then I did
switch the
slides, right?
Oh wait, hold on. Sorry. There you go.
Okay. That's what happens when you jump around too much. So thanks for coming today. I'm going to talk a little bit about our experience with MediaConvert. We were an Elemental customer. We've been using Elemental for a couple of years now, and we've been through the beta program with the AWS folks, and we want to sort of share how it worked for us and how we've used it for some of our customers. So I'm the CTO at OwnZones, OwnZones Media Network. We've been around for about 5 years. We're one of those sort of middleware companies in the OTT world. Our whole goal is to be part of that transaction. So just like you use MediaConvert for transcoding, S3 for storage, CloudFront for streaming, we've got a lot of IP and products around ingesting content, managing the content, and then delivering it through to the end customers. We've kind of got this goal as a company in the end. How many people here are from video, like post-production houses? There's a show of hands, a few people, yeah? So we have this vision that just like you used to have file servers inside your enterprises and mail servers, remember you used to have like Microsoft Exchange servers inside your enterprise? We have this vision that using the cloud and using all these building blocks you see today, that we're actually going to be able to start to move a lot more of this post-production software. So your clipsters and your color fronts and transcoders and some of those high-end editing tools, we have a vision to be able to move that to the cloud. And especially with some of the machine learning that we're starting to see come, the process now of taking a mezzanine file to post-production and having somebody open it up in a very high-end workstation and edit that file and work on it for hours, we're starting to find that we can do a lot of that, maybe even more reliably using AI, machine learning, the cloud, and all these building blocks we get from AWS. And so that's what our focus is as a company. We provide a bunch of different solutions out to the market. The one I'm going to show you today is called Connect, and it's this video workflow system we have. But we also do have a content management system and streaming platform, so we actually do build white label applications for customers too. So if you want your Roku app or your Amazon Video app, or you want to be out there on Android or on Metrological in Europe or somewhere like that, we build apps as well for customers. The cool thing about the platform that we have and all these different building blocks we get from AWS is that once we've got those files in there and they're ingested, just like Vivek was saying, it's just another output profile to go to HLS or HLS, with Dash, or, if we want to do DRM, it's all in the system and it's all in the cloud there. We have some unique IP as well, and I'm going to talk about that a little bit. We're using almost every Amazon web service that you could use is actually part of our solution. This is our Connect product. I'm going to demonstrate this to you more than anything. There's a couple of things if I don't show them as we go through. We have this philosophy of ingesting any kind of file and identifying what that file is and working out what the best path for it to go through Media Convert can be. And so with all the settings that Vivek just showed you, with all the options on the transcoding and the clipping and changing the interlacing and messing with aspect ratios and all those things you do, what we've been working a lot on is being able to automate that and detect that in the files. A lot of our customers are studios that have libraries that are 20, 30, 40 years old. And the big opportunity for them today is to take all that content and get it into your Netflixes, your Amazon videos, your Hulus, so that they can monetize that. The challenge that they have is that those files are in all these crazy formats, shot on all these different cameras, edited by all these different post-production facilities. And so they're not standardized and they're not conforming. And so it's very tricky if you don't know what you've got going into a platform like Media Convert, then it's very hard to predict what you're going to get out. Because Media Convert does exactly what it's told. And so, you've got to make sure that you're feeding good content in to get good content out. Something I'm not going to show today, but something we've done a lot of work on in the community too is IMF. And we actually use all the Amazon web services to do elastic transcoding where we can do parallel IMF processing as well. This is what our platform looks like for the developers in the room. As I mentioned, we use a lot of AWS. Files come into S3. They come in through a variety of ingest methods. We use things like Aspera and S3 copies and Signiant, and there's a lot of industry tools out there that companies have standardized on. Once those files come into S3, we have our Connect framework. We use Amazon Workflow with deciders in it. We're using RDS and we're replicating our databases. Our whole system is actually fault tolerant and it runs in multiple availability zones. So we can have files that come into S3 and we can, balance it across to the East Coast or move it across to Europe and process it in a different availability zone. As you sort of see the architecture here on the top left-hand side, we have mobile clients, Android, iPhone, Roku, all that sort of stuff, and they come in through Beanstalk, through a REST API, and we're starting to move to Graph as well, and the whole framework is actually based on Node. So everything you're going to see today runs through a Node.js interface. Up on the top right, you'll see that we've got Media Convert. That's what we used to use the Elemental Server for. The big reason that we are really, invested heavily into the Elemental and the Media Convert strategy is that our customers are studios and they need extremely high quality output files. When you're talking about HDR, SDR, ProRes, mezzanine, you need a transcoder that can actually deliver on those very high bitrate files, complex file structures, complex metadata structures, especially with HDR, and do that at scale. And so that's the reason that we've really invested heavily with the folks at Amazon in our platform. I'm going to tell a quick little story about a customer of ours called Magnolia. Magnolia Pictures is a studio. They're also an aggregator and distributor of content. They're a sort of a mid-sized studio. It's really interesting for all of the content creators today and the studios. They're in this sort of predicament. They have a lot of content, and there's a lot of opportunities to move that to streaming services. Go and put this in some country on some OTT over-the-top platform. It's really hard for them to actually know what the ROI on that's going to be. If you go and you take a whole library, you take a couple of thousand movies and you put that into, a streaming service maybe in Europe somewhere, in Germany or somewhere like that, the cost to conform those files, transcode them, build the metadata around them, and actually get them all over there, for that promise of let's hope and see if we're going to get the conversion and the return on investment, right? And so for Magnolia, that's one of their challenges. Every time they get an opportunity that comes to them, they have to understand what the cost is going to be to get those files delivered into those OTT destinations. And then one of the other challenges is for a lot of these content aggregators and distributors is they buy a lot of the content. So it's not like, it's 2017 and everything that's coming off post-production is HDR or IMF, and it's a well-known format and a well-known spec. They're buying movies from 20 years ago and libraries from 20 years ago, and the state of those libraries when they buy them is pretty unknown. The mezzanine files have all sorts of different configurations and settings. And then the other thing that happens quite a lot is these opportunities come up for customers like Magnolia, and very quickly they have to launch a service. So recently we launched Amazon Germany, Amazon Japan, and for Amazon streaming video. And as we launched those services with our partners, it wasn't, hey, we need to get, 20 or 30 movies here. It was like, we need to get 1,000 movies here in the next 2 weeks. And so that's 1,000 sets of files with 1,000 subtitles and 1,000 sets of, captions and metadata and all of that stuff. And so, the promise of the cloud is really, sort of what's making us successful right now is this ability to scale up and scale down, pay for just what we use, and really kind of take advantage of all those AWS building blocks is what's making that easy for us. So this is the workflow that Magnolia uses through our system, and I'm going to demonstrate it in just a minute. Files come in to S3, much like Vivek's diagram before. We get files in all sorts of crazy ways. Hard drives, we get caption files emailed to us, and because you have a delivery window, we may have a couple hundred movies come in, and then we load them into our system, and it actually analyzes them and works out what's missing. And then we have a very short window to actually get all those pieces we need to be able to get the jobs through the system, through the cloud, and delivered. Something that we do, which is fairly unique, and it's kind of a little secret to our success, is that when the files come in, like a ProRes file comes in, we actually demux it. And so we split it out, and we split out the audio tracks, and we split out the video, and we really digest that file. And then once we digest it, we run these inspection processes on it. And so we're using Elastic MapReduce, and we're scanning the files, and we're going through all of the steps that like a Deluxe or a Technicolor or your big post-production houses go through when they get a mezzanine file and they have to deliver it for you. All those manual steps that those people go through, all those tools that they use, we've taken all of those processes and we've put them in the cloud now. So when the file actually arrives in our system, it gets all those checks down on it before we start working with it. And once we get to this, what I call the recipe of conforming, that's when we know what do we have to do to mess with that mezzanine file to get it to be in a good state to go through Media Convert and come out with a successful transcode, right? And so sometimes we'll get them with the bars on the beginning, sometimes we'll get them with different aspect ratios. Sometimes the aspect ratios will change during the movie. And so we've got to look for all those things. Sometimes we have dead, black spots that, don't move for, thousands of frames, and you've got like a little black dot in the top right corner or whatever. There's all these things that we have to look for before we want to go and run it through the transcoder. We then move it into batches with jobs, and we bundle together all those things. The recipe, we have something we call the CPL. We kind of stole that from IMF. It's the ingredients of how we're going to put the files together. Pre-roll, post, audio tracks, bugs, all those things that you do. If you're on American Airlines and you see the American logo down the bottom right when you're watching that movie, that's the bug that's coming in every 5 minutes, right? We have to tell the transcoder up in Media Convert all those things before we send the job to it. We run it through Media Convert, and then it comes out and we actually repackage it all back together again, and then we run through automated QC. So that's sort of the workflow that we have. And I'm gonna demonstrate that here, and then I'm gonna go back and just tell you a little bit about how it works. So this is our platform. It's up in AWS. View, I'm just going to go full screen. Our customers log onto this themselves. It's self-service, it's SaaS. So they come in and they get a dashboard that looks like this. The first thing that people normally look at is their ingest, because they're looking and seeing all the files that have been coming in. And so here's a ProRes file that's just come in. And here's the inspection process that started on it and run through it. And we've gone through and we've looked at the interlacing and the scans and the streams. In fact, this one doesn't actually have a lot. Let me see if I can find a better one. Have a look at this one here. So this one ran through, and what happened was it was looking at the interlacing and the aspect ratios, and it actually found an issue. So then we ran more tests. So in the post-production world, there's sort of like flow charts of, we're going to check this, then we're going to check that. Then if this is this, then we're going to check that. And that's kind of how you build that recipe to get to conforming. So our system's doing all of that, and it's coming through and it's analyzing the audio tracks, the crop settings, all of that stuff. And if this one actually needed something to be done with it, the actions there would light up. And we've actually automated our system to about 20% of the files that come through now, we can actually fix them on the fly. So with the machine learning and the AI stuff that you've been seeing here at reInvent this week, we're putting a lot of work into that right now, because our vision is that we can go and we can scan a library, maybe it's 20 or 30 years of television or something like that, and we can come up with all the machine learning on what we have to do to conform it, so then we can run it through Media Convert on the fly, and we can deliver it out for OTT. And we're able to deliver things in hours that take traditional companies days and days. So that's the ingest side of things. Here my batches are. Batches is basically a group of jobs in our system. These smart agents are running, and they're actually telling us that we're missing some metadata or we're missing files, which means that the studio maybe didn't give us everything we need, or they gave us some metadata, but Amazon Video, for example, has a really long description requirement, but that's longer than what Comcast Video wants. So if you get one metadata file, it's actually not going to work for both, for example, so our system would flag that. I'm going to go into Magnolia here, and I'm going to go find some jobs. And these jobs get hydrated up as the files arrive. And let's just grab a couple of them here, and I'm just going to start them. And then once I start them, I'll show you what's actually happening. So rite of passage is running. The system went through and it analyzed the files. The source files have already been demuxed. And so this has got a pre-roll on it, and then it's got the trailer. And so it transcoded the pre-roll in 0 seconds. Did you see that? It did that because what we do is we actually cache everything we send the transcoder. And if we've ever done that before, we don't go to the transcoder again. We use it out of the cache. And so the pre-roll, why do we need to transcode that every time when we've transcoded it once and we've got it sitting there in cache? And so what this is doing right now, I'm going to hit View Workflow Execution, and I'm going to go out into Amazon Workflow, and here is the workflow that's running in SWF. And if I click this, I can see all the events that are running right now. And so we're using the decision. So what have we got, about 40 or 50 events? And somewhere in here, if I find my activity, Now if I find my transcode, here's the content. I had to scroll quickly so you didn't see my API key. Here's the content that is getting sent off to Media Convert, right? So our system is using SWF to build the workflow logic. It's looking at all those conditions we talked about on the ingest, on how to make it conforming. It's making all these decisions about what to tell Media Convert to do, and then it's actually invoking Media Convert here. And if I go, if I go back to my console here, my job is finished. And if I go and click on this tab, it will launch me into Media Convert, and here is that job that Vivek showed that he built. Remember, he built that manual one. Here's the one that our system actually built and generated. And this was a very, very simple job. It's just an MPEG-2 single pass. It was for the demo, right? I wanted to run fast. But you can imagine when we're taking HDR and we're taking, these super complex files and we're stitching together lots of different pre-rolls, and we've got a bunch of audio tracks and all of that stuff, how complex this gets, right? And so the secret sauce for us is being able to have this relationship with Media Convert where we're able to basically inject into Media Convert the recipe that we need to get this to work for us. So that's a sort of a quick run through of how we use Media Convert. There's a couple of other things that are quite interesting in the way that this system works here. You'll see that we concatenated the files back together again at the end. So we don't send like the whole job to Media Convert, we send it in pieces. So we can cache them again and again. So we only have to do the same thing once. And so most of our customers that do OTT will give us a file. Say we get Terminator 2, right? It comes in, it's got to go to 10 different OTT delivery points. 6 or 7 of them actually are almost identical. They all want, ubiquity in that. They all just want like a good HD file. But, they want to put a different pre on it based upon the relationship they have with each of those. One's at Comcast and CIM, and one's out there at Dish, one's at DirecTV. And so we will only actually do that transcode once, and then we'll just concatenate the different heads on it and then run it out and run it through. We also integrate with Quasar and Baton for automated QC. So by the time the file comes out of our system, and then we automatically do Aspera deliveries as well. If it passes our QC, it should never get rejected by the endpoint, hopefully, because what we want to do is we want to have the same QC profile that they have so that the files always get through. So that's just a quick demo of how we're using Media Convert. And I'm just going to go back here to talk a little bit about what our experiences have been with Media Convert so far. As I mentioned, this is definitely the most sort of industry-grade broadcast quality transcoder you can find, in Elemental and now in Media Convert. And so all that learnings and all that knowledge, and I say that because we have to deal with some really tricky situations. Some of the more legacy cable-based platforms, have different frame rates and just a weirdness in the way they do their video specs. And we want to have one platform that we can, send that same file through to get out to that cable operator as we can out to, someone that's much more advanced, like a Hulu or a Netflix, that, has a much more advanced sort of HDR. They want the best possible file, right? And so we definitely find Media Convert can do that for us. Our system is very queue-based, as you saw. Every one of our customers has sub-orgs, and sub-org customers have their own queues. But what we used to have to do in the server world was we'd have to sort of spin up elastically those Elemental servers, and we had to know what was coming. The ability now just to shove stuff in the queue and know it's coming back out and not have to deal with that is pretty amazing. Because, the idea, like Vivek was saying, the idea of forecasting and managing your queue length quite often used to manage your workflow based upon how many servers you wanted to have running because that was a cost. Now that it's truly per minute, you could do it all today or you could do it all over the next month. It's going to cost you the same amount of money, right? So for us in our business now, when Magnolia comes to us and says we've got to drop, all of these movies out to Amazon Germany or something, it's like, great. We're just going to fire them in the queue, parallel scale it. And everything that we're doing inside our system now is becoming, with Scalar and Apache Spark and stuff, we're trying to do everything that we can in parallel. And so the idea is now is that, no one job should block another job. And we're just about there. CloudWatch is awesome. So now we get an integrated report and view of what's going on. So we have a single view of the transcoding farm and Media Convert, as well as all the other AWS services. And a real big deal for us is this IAM role thing. Our architecture is that a customer, the customers that use our system and the post-production houses that use our system, because we don't just offer the service to studios, we're also just launched a new offering where post-production facilities can use our platform too. But the whole idea is that you can bring your own credentials for your own buckets. You can bring your own compute, credentials. You can now bring your own Media Convert IAM credentials, and then you can use your own Aspera key, and so that you can pay for all your own resources, and then you just use our platform to manage it, right? And so this IAM role thing is really cool because now customers, can see on their own Amazon bill, their compute, their Media Convert, their S3 storage, and they can control, their own destiny. We don't want to kind of, hold them hostage by having all the files in our accounts and our buckets. And frankly, from a security perspective, I'd much rather have the studios control their own security and not us administrating their security. So I think that's huge. And then the other thing that is really neat now is we used to have to, when you upgrade servers and things like that, you used to think about it as a server. Now we just think of it as an endpoint. And so if we want to run a new version of Media Convert, or we want to do something, we just change the endpoint in the API. So it's very, very seamless. The role of the DevOps person that used to help more to manage the transcoder farms is quickly diminishing now to where it's becoming much, much more self-service. Use it as you need to. And that's a good thing, I think, for all of us. So, in closing, Media Convert's worked really well for us. We're super excited about the product. And we're also, it supports our business model. We don't own any servers. We don't own any big licenses of any software, right? We use a lot of open source stuff. But it supports our business model because we don't know tomorrow how many movies we have to deliver. We have no idea. And we also, from a cost perspective, we don't want our customers to have to go and spend $100,000 on a video editing bay and a trained operator when they can come to the cloud now, self-service upload their files and ingest them and deliver them in these very advanced formats, right? So this whole AWS Media Convert business model works the way that we work. And so I think that's probably the best thing about how we're aligned. And then the other thing was that we use Node to abstract all of our services or microservices. So when we actually went to plug in the Media Convert API, I thought it would take like a week. It took like a day. Our developers were just like, this is easy. It's JSON. It takes all the old parameters. We can use the profiles that we already used to use. And so it literally took like a day or two, and I had Media Convert running in our platform. And we've just been converting each customer over to Media Convert one by one as we QC the output and stuff like that to make sure we're getting the same results. And our goal over the next month is to have 100% of our file-based deliveries all using Media Convert completely. I'd say we're already about halfway there with our customers so far. So that's it for me. Thank you.